Okay guys, welcome back, and let's try to do another mole concept question. Alright, so what we have here today is zinc carbonate react with hydrochloric acid producing zinc chloride, carbon dioxide and water. Alright, and we are given 0.1 mole of zinc carbonate reacted with 0.3 mole of hydrochloric acid. And the first part is that we are required to find the determine the reactant, right? Which one is the limiting reactant and which one is the excess reactant. Okay, so from the balanced chemical equation here, zinc carbonate, right, is to your hydrochloric acid. Okay, so we know that from the chemical equation, this is a balanced chemical equation here. 1 mole will react with 2 mole of hydrochloric acid, 1 mole of zinc carbonate, right? So, and the given amount, right, from the given amount is 0.1, right? Instead of 1, they give you 0.1. Fair enough, right? 0.1 is to 0.3, right, of acid, 0.3 mole of acid. Now, we've simplified this 0.1 and 0.3, we get 1 is to 3, right? Okay, that means obviously we know that our zinc carbonate here is our limiting reactant. Limiting reactant means it will stop. Zinc carbonate, once zinc carbonate ends, finishes, right, the whole chemical reaction stops, and the excess reactant, right, this will be the excess reactant, right, your hydrochloric acid will be the excess reactant, because by right from the chemical equation here we only need 2 moles, but they give us 3 mole, right? So since they give us 3 moles, so there is an excess of 1 mole of hydrochloric acid. So that is your excess, right? That means after everything finished, stops, after the chemical reaction stops, you will still have extra of 1 mole of hydrochloric acid. That's what it means, huh? Alright, then we go to the next question, the part 2. Alright, the part 2, they tell us to find the number of moles of zinc chloride and carbon dioxide produced. Alright, your zinc chloride and carbon dioxide. So your zinc chloride, ZnCl2, is to your carbon dioxide. You know that it is still 1 mole is to 1 mole from our chemical equation, right? And we will use our limiting reactants, right, which is 0.1. That means it will still produce 0.1 mole of zinc chloride and 0.1 mole of carbon dioxide. Simple as that, right? So from here, that's all about it. That means the number of zinc chloride will be 0.1 mole, right? The number of carbon dioxide produced will also be 0.1 mole. That's all about it for part 2. Done deal. Okay, part 3 is much more interesting. They ask you to find the mass of zinc chloride and volume of carbon dioxide, right, at RTP. Okay, all right. So we know that 1 mole, right, 1 mole of zinc chloride, the MR, okay, will be equal to what? Zinc is 65, the AR of zinc is 65 plus 2 times 35.5. That is for your chlorine, right? Y times 2 because there's Cl2, right? So total up is what? 71 plus 65, that is 136, right? 136. So we only use up 0.1 mole. So 0.1 mole of zinc chloride, that will give you 0.1, right? 0.1 mole divided by 1 mole, right? Divided by 1 mole, okay? And multiply by 136. That will give you the mass of zinc chloride, okay? That will give you how much? That means obviously will be 13.6 gram, right? The mass of zinc chloride that will be produced, right, when crystallized from aqueous solution, obviously, right? And we are required to find the volume of carbon dioxide, because we cannot we need to take note that carbon dioxide is in the gaseous state, right? So volume of carbon dioxide in cubic decimeter, we know that 1 mole of carbon dioxide, right, will be corresponding to your 24 cubic decimeter, right? Okay, and we only use up 0.1 mole, right? We use up 0.1 mole of carbon dioxide, right? That will give you obviously 0.1 divided by 1 multiplied by 24, you get 2.4 cubic decimeter. That is the volume of carbon dioxide produced. That's all about it. Okay, no formulas, no need. Okay, that's all folks. Thank you very much. Thank you for watching. Bye bye, take care.